is Dan with Cable Bullet.
And I'm Chris.
Today we're going to be looking at our Signature Series aluminum posts top mount installation.
We're going to be installing these posts on a 12 by 25 foot deck, one set of stairs off the side. Then we're going to be installing our aluminum handrail and Cable Bullet tensioners.
Let's take a closer look at our Signature Series of posts. The top is a machined stainless steel top. It is adjustable for straight or sloped applications. The wall thickness of the post is 1/4 inch thick. The holes have been drilled and pre-tapped for our Cable Bullet tensioners. The base comes with a cover plate to cover the mounting screw holes and the screws that are used to level the post. The Signature Series of posts comes with several types of posts. We have the end post, which will have holes drilled on one side, a corner post with holes drilled on two sides, and a through post, which will have holes drilled on opposite sides of the post. These are all tensioning posts.
For today's project, we're going to be working on a 25 by 12 foot deck with stairs coming off one side. We're going to be using 3 corner posts, 4 end posts, 1 two-way post, and 5 structural intermediate posts. To minimize cable deflection, we're also going to be adding 7 spacer bar kits anywhere the cable spans more than 4 feet between posts.
The most difficult part of laying out posts on your deck will be the stair section. We'll take a look at that section first, and it is advised that you lay out the posts for your stairs first before moving on to the rest of the deck. In placing the posts on your deck, you'll want to make sure that the frame under the post is well blocked. There's a lot of tension in a cable system, and it's necessary to make sure that the base of that post has solid blocking beneath it to adequately support the post. Let's take a closer look at installing the post location on a set of stairs. Note that the tensioner is on the face of a 2-inch thick post. This means that the tensioner location is going to be different relative to the nosing of the stair if you place the post equidistant from the nose. In this location, because we don't want to move this post far back on the deck, we want to keep it out towards the front. It's going to create a problem at the bottom end here. I'll illustrate that here. You can see that our cable in this application would not be parallel to the stairs. So what we're going to do is set up a string here to show you about where that cable is going to run, about in here, okay? And you can see where that does not line up with the bullet hole down here. If I tried to move this far enough out to catch that bottom hole, I'd be completely off my tread. So the solution is to bring your post in either to this location where it meets this, or in our application here, we're going to come all the way into here and have this third hole line up with the correct slope of the cable. We'll use a 42-inch post. That's 2 holes taller than a 36. It'll allow our top to plane out just right. This post shows the post hole plugs in the bottom 2 holes and then tensioners there on up. This allows us to move that post right in close. We'll be using this tensioner to align with the upper tensioner here. This is what that post hole plug looks like. Right. To drill these holes, we used a 7/32 size drill bit here. We're going to be driving these GRK screws in. They're 4 inches long, 5/16, and they're designed to fit nicely into the countersunk recess in the base. So here we've pre-installed some of our bullets. You'll need to leave them off on the bottom or entirely in order to keep your plate out of the way while you do your work on the base. Okay. Now, we're going to use a level here and check level on our post. This direction I'm in good shape, but this direction you can see I'm not. Need to raise this side of the base. So this is where those adjustment screws come in handy. I'll loosen my screws on this side. And use the Allen wrench to drive these set screws down. I'm going to recheck for level there. Looks like I need to go just a little bit farther. There we go. Okay. Reset these screws. And we should be in good shape here. Yep. All right. That post is set. We'll now move on to the other posts around the deck. Here we're preparing to set the intermediate, finding its location on the stair run. So we've run a string down here simulating where the cable location will be, and we move this intermediate back and forth until we line up the hole in the intermediate post with the cable location. The Signature Series line of posts will handle about any handrail that has a flat bottom, can be applied to it. Today we're going to be using Cable Bullet's matte black, aluminum extruded, structurally reinforced handrail. This has a real thick web top and bottom, allowing it to span long distances between structural supports. Cable Bullet's engineered handrail gives you some pretty neat options for making connections with your handrail. We have a structural spline that allows a break in the handrail to happen anywhere in the length of the profile. You don't have to break with a structural spline. You don't have to break the handrail over top of a structural support. The handrail itself can span 7 feet in a simple span and 8 and 9 feet in multi-span applications. Okay. Another option for making connections with this handrail is the corner spline. This is a very durable plastic corner spline, Delron, and it's designed to fit into the corner and give you a nice 90-degree corner connection. This is a machined adjustable spline that comes in several components, 2 components, that can be configured in several ways. This would be an end part to the spline, and this would be a lap part to the spline that can create a variety of configurations. A bolt is placed through the spline and tightened up to give you to set the angle for your spline in an angled application. Right. Another option for creating connections with your handrail is our spline stock. Now this is designed to be cut down and used in short pieces and used to make unique connections. So here we have a piece that we simply screwed together to make a unusual connecting joint. It's designed to slip inside the profile, and then another piece can be slipped on there. All right, we're going to show a little trick right now to how to find that angle that you'll need in running your handrail down a set of stairs here. So what we've done, we've got a 2x4. It's touching the nosing going down the stairs here. We're going to bring another one in here right alongside it. And you can see that forms an X. We're going to take some clamps on here and tighten that up on here. Okay. I'm going to take a square, drop it right in here, till that square touches both those boards. And I'm going to mark right across there. I'll set another square, or another clamp on here, tighten it up. Now I can tip this over and do the same on this side here. Now that I have these 2 points marked on my 2x4, I'll take my clamps off. And I'm going to mark between these 2 points. Now, this angle is exactly what I need to cut to form the transition down a set of stairs. Now we're going to take our 2x here that we've marked our line on. We're going to set it up in the saw and adjust our saw angle so that it aligns, the cut will align with my mark. This gives me the angle I need for my stair transition in the handrail. Now let's take a look at our transition of our handrail from a straight section around a corner and down the slope of the stairway. So we've mitered our handrail to make that nice smooth transition coming around the corner. Now we need to angle the handrail down. So we're going to break that handrail right at the face of the bullets here. The face of the bullet is where the cable will start to head down, so we want our handrail to follow that same trajectory down. The thickness of the head of the bullet is about 1/4 inch. Our handrail is the same thickness as the post, so coming off this corner by 1/4 inch and starting my break there will give me just what I want for the angle of the stair down, the angle of the handrail down the stairs. To make these miter cuts and compound cuts in this handrail, we're using a miter saw with a high quality blade that's designed for cutting metal. Here we've marked our transition, and we're going to cut that handrail right on our mark. Now that we've made our cut, because the profile of the handrail is identical, we can simply take that handrail, flip it over, and I now have the transition for my stair. We're going to use our adjustable spline kit to assemble this joint. I'm setting the angle of that adjustable spline to the angle that we found is the right angle for our stair assembly. Used an Allen wrench to tighten that up. And it's simply going to slip right into here. Our next piece slides into here. With that securely in place, I oftentimes use tape to help hold that joint in nice alignment while I'm drilling. I'm using this slightly larger drill bit that matches the head of my screw to create a countersink for my screw. To assemble this handrail, we're using stainless steel sheet metal screws. These are number 8 by 3/4. You can see that's already really tightening up quite nicely. Now we're going to countersink for our next piece. Okay. We've finished assembling the transition here down the stairs. Notice we've put all the screws on the underside so that when it's assembled on the post, you won't see them anymore. And these are the steps that you would typically use for drilling, countersinking, and screwing most of your spline assemblies. Okay? To help us manage holding the railing in place while we're assembling it, we have a handrail clamp that's designed to capture the head and the handrail and clamp down tight. This is a really good idea to use something like this when you're running these screws in from below too. The clamp is designed to stay out of the way of those screws, and it will, because you're drilling in metal, the drill will want to walk, and this sort of a clamp will help keep that to a minimum. Here I'm using a square just to make sure that my post and my handrail are aligned. There we go. Now I'm going to use the other clamp to secure the railing. This clamp really secures that rail nice and tight so I can work on these screws, work on the other end, and make sure everything stays put right where we want it. The next step here is to create the final transition here. And again, we want to break our handrail over top of the face of these bolts, because that's where the cable is passing through. If I don't, if I tip this out and move this up here, what I'll do is create a different distance between the handrail and the cable. So this is why we pull it down and we create a mark, the face of the bullets, right on our handrail there. So that point is where we'll want to create another joint flattening this handrail out. Now we're going to assemble this spline, or this joint at the bottom of the stairwell with a piece of spline stock. We'll just create a spline to make this work. I'll be cutting the angle in here just the same as what we did for this transition here. And then we'll screw those two pieces together. That'll give us an internal spline that'll secure the joint. In making this spline up, I'm going to make sure that I don't run this spline too close to the end, because I do have an end plug that needs to be inserted in this end. It takes about ½ inch at the end. So I'll make sure I stop my spline short of that end plug. These two pieces will be screwed together, giving us a secure joint to fasten this end plate on. See, we've created a spline there. I'm going to put another one in here. There we go. So here we're going to assemble this mid-span joint with our structural spline. I've inserted this spline into this half here. I'm going to take this handrail piece, line it up. And there we have a structural spline. That spline is quite durable and sturdy, and will hold that joint just fine. You can break it in the middle of the span and not have a problem. Now that our handrail has been created to transition this section of railing, we've got our handrail clamp on here to hold this joint securely in place. We're going to take a drill pilot holes for these sheet metal screws, the number 8s, and we're using a 5/32 drill here, and we're going to drill in insert our sheet metal screw, stainless steel sheet metal screw. There we go. Now with our handrail fastened here, we'll loosen these clamps, take those off. I'm going to take out the pins. A little easier to take off this way. There we go. And I'll finish screwing on the back side of here to fasten this in tight. With these, with this thick handrail, thick-walled handrail, all we need to do is penetrate that handrail with our drill bit, and the screw will grab a lot of material in there and secure that top to the handrail quite nicely. So here you can see we have a split in the handrail that is not falling over a structural post. Because of the engineered design of the handrail and the structural spline, that is okay. We're going to insert this structural spline, and we're going to slide it in here. And we'll need a little tapping on the other end, and it'll drive that together. And we'll have a structural spline. One more pop there. Perfect. Now we have a structural joint that does not require any support under it to be fully load-bearing. We've assembled this section of railing. The last thing to do on it is to put our end cap in the end here. The end cap has a partial tendon on the back of it that will fit into the end of the handrail. It does take a little bit of a tap with a mallet to drive that in. And there we have a completed handrail section. These are the basic steps to locating posts and installing handrail. You'll always want to install your handrail first before tensioning any cables.
Once you've finished installing your handrail, you're ready to move on to setting your tensioners and running your cables. We're going to be showing you how to set your tensioners and run your cables on a 12-foot section with one intermediate post supporting the handrail and 2 cable spacer bars on either side supporting the cable. First step is to set all of your cable bullet tensioners. These tensioners are designed specifically for metal posts. And they're going to thread into this quarter wall aluminum. You'll notice there's a rubber O-ring right behind the head of the tensioner, and this is designed to give you a full rotation so that you can angle the set screw channel to the desired location. These will spin in fairly easily by hand. Once those are hand tight, you can use a socket wrench with a 7/16 attachment and our cable bullet driver to rotate and set them in their final location. We've just completed setting all of our tensioners and aligning the set screw channel to be at 6 o'clock. That's more for aesthetic purposes at this point. Before setting any of our cable ends, we're going to put a few drops of BoShield T9 lubricant into each of the cable bullet set screw channels. This is going to protect the stainless steel, and it's also going to ease the installation of that set screw, especially when we start to put tension on them. It'll reduce the likelihood that we have any seizing up or galling. Each cable end is going to have the same 2 components that are going to be crucial to tensioning the line. We've got a cable bullet lobed washer. This part is free spinning, and a crimped cable end. This end has already been prepped, but we're going to go ahead and show you how to do that with a fresh piece of cable. First, slide the lobed washer over the cable end, and as you do that, you'll notice the importance of having a good pair of cable cutters, because if that cable end is frayed even just a little bit, you're not going to be able to fit the parts over. Once the lobed washer is on the cable, you fit it with a stainless steel crimp sleeve. Set your crimper, and it will take about 10 to 12 pumps to get the die to seat tightly. And once it does, crimp down hard and release the crimper. This will give you a nice hexagonal crimp that's going to seat tightly against the cable and hold up against the tension that we're going to apply later on. To help speed up the process, we went ahead and cut rough lengths of cable and finished one end with the lobed washer and crimp. Now we'll go ahead and take that crimped end, fit it into the cable bullet, and take our 3/32 set screw with the 6-inch long hex driver in a socket screwdriver to set the set screw. We do not recommend using a drill to do this. Although it may seem tempting, you will run a much higher risk of cross-threading or seizing up that set screw in the process. Before we set the remaining cable ends, we're going to go ahead and thread our first cable through all of our intermediate supports. Because this is a 12-foot long section, we have one structural post to support the handrail and 2 cable spacer bars, one on either side, to help minimize cable deflection and stabilize the railing. We're on the other end of that cable run now. So you can see we've put 3/4 inch painter's tape on this post, and we're going to take our line, our rough cut, which is too long, and measure 1 inch past the face of this bullet, or 3/4 of an inch past the face of the post. We'll pull a nice hand-tight line, mark that area, and make our final cut. Now that we've cut and prepped our second cable end, we're going to go ahead and insert that into the cable bullet. Use another set screw to lock it in place. The goal at this point is to have very little slack in the line, so that by the time we engage the tensioning mechanism, we're tightening a fairly hand-tight line without too much slop in it. Advancing the set screw on either end is going to draw the cable deeper into the post and tighten the line. You can see here we taped our cable spacer bars to this intermediate post. There's 2 reasons we did that. The first is that while we're pulling these cables tight, we want to make sure that these aren't slopping around and dragging the cables down, so we're getting a nice hand-tight line. The second is that the holes in the spacer bar and the intermediate post are only large enough to allow the cable to pass through, not the cable with the crimp and the lobed washer on it. So it's very important to pull the cable through first before setting your second end. If you cut short or you forget to do that, you'll have to cut your cable and start over again. Now that we've finished securing both ends of our first cable and our spacer bars are locked in place, we're going to go ahead and finish out this entire run. Now that we've finished setting all of our cables, we're going to go ahead and tighten everything up using the 6-inch hex driver or the 3/32 Allen key. We're going to start in the center and work our way out until everything's nice and tight. Now that our cables are all tight, we can move the spacer bars into position. We've centered it up on this run here. And with the floating spacer bar, we've got set screws top and bottom. Right now they're loose. Just go ahead and use that same 3/32 Allen wrench and lock that in place, keep it from moving, top and bottom. One of the questions we get a lot is, how tight should I tension my cable railing? And without specialized equipment, there's no exact way to tell, but this Allen key will allow you to comfortably tension to about 150 pounds of tension per cable. That's going to feel about like this. So there's still some deflection, but you have to press down pretty decently to get there. You can certainly go a bit tighter, but as you tighten them up, just make sure that you're doing so carefully and keeping an eye on not stripping out the set screw as you do that. One more thing to note, it's perfectly normal that after a new deck settles or you have the natural contraction and expansion associated with the temperature, that you will have to go back after a week or 2 and possibly next season and retension these wires. They're going to slack off a bit, but if you followed our instructions, you should have plenty of room on both ends to retension the wire as needed. Thanks for watching this installation video. If you have any questions at all, don't hesitate to call us, email, or leave your comments in the comments section.